Good evening, dear all. We shall continue the topic rules of significant figures. We have already discussed in the previous video the point number 1 and the rules for the significant numbers to decide about the zeros. That is the rules for the zeros. Okay, so in the rules of the zero, as can be seen at the board on the board, that if at all the zeros are in a non-decimal number, that is a number with no decimals in it, then they have to be considered not significant. Here we have number with a decimal in it, then the trailing zeros or the zeros in between have to be considered as significant, and the number and the zeros which are in the front, they have to be considered non-significant. These examples we have already done. Once again I will write here. Suppose I have a number with no decimal, then these two zeros are the trailing zeros and they are not significant. I have another number with a decimal. Here I have two trailing zeros also, a zero in between also, between two non-zero numbers also, and zeros in front of a non-zero number also. So there are three types of zeros here. So which are to be considered as significant? These are not significant. These are significant because they are between two non-zero digits, and these are also significant because they are trailing zeros for a number less than 1, that is a number with a decimals. Okay, so this rule again we have revised from the previous video. Now in this case of the rules which we have made for the zeros, there is a small confusion. We also said that the unit will not decide or will not finalize the significant numbers. We also said the decimal will not finalize the significant figures or numbers. But here we can see I have considered one number. This number is from textbook only, where we can see that 4.700 meters is equal to 470.0 centimeter is equal to 4700 millimeter is equal to 0.004700 kilometer. Now here they all are equal to each other and we have changed their units. Correct? In that case, when we follow that rule, here I will get 4 significant numbers according to that rule. Here also I will get 4 significant numbers according to the given rule. Here I will get only 2 significant numbers because the given rule is saying that if this number does not have a decimal, then these two are trailing zeros and they are not significant. Here again these are not significant and we have 4 significant numbers. So here there is a confusion that when I change the unit, the rule didn't work out. Now to remove this confusion, to remove this ambiguity, when a measurement is made and reported, we write it in the form of a scientific notation. Okay, here this is the point number 3 in the main topic of significant figures. This is point number 2. So we write scientific notation as the measurement is reported. Now what is this scientific notation? It is in the form of A into 10 raised to B, where A is any number between 1 to 10 and it is called as the base number. B is a positive or a negative power of 10. It is also called as the order of magnitude. So, now using this type of a scientific notation where A is a number between 1 and 10, B is the power which is also called as the order of the magnitude, we rewrite this confusion again and find out what are the significant numbers of the given question, and let us see how does it relate with the confusion given as the rules for 0. So now we will rewrite this number. This is same. So 4.700 meter we rewrite. How many significant figures does it have? 4. 1, 2, 3, 4. According to the rule given. Now this number which I have changed the unit, so I can write it as 4.700 multiplied by 10 raised to 2 centimeter. Can I do this? Yes. Okay. So again, how many significant figures does it have? 4. Because the base number has 4 significant figures, we are not to be considering the power for the significant figures or the numbers we are counting. Just like here also, this power need not be considered for the significant figure. Only we have to consider the significant figures as per the rules for the base number, not for the power or not for the 10 at the base. Fine? Okay. So we rewrite this example again as 4.700 into 10 raised to 3 millimeter. So how many significant figures? 4. Here, what do we write? 4.700 into 10 raised to minus 3 of a kilometer. Same number I am converting, changing the units. So how many significant figures are there in this case? 4. So I have changed the unit of the number by just multiplying its respective power with the base 10 and found out the significant numbers of the base number, which is same for all. So two rules are confused, which were confused have been removed now. What are the two rules? The change in the unit does not change the significant figures, correct? And the change in the decimal also does not consider or do not have any role to play in the significant figures. Fine. And we have to write the measurement as a scientific notation given as A, base number into 10 raised to B, that is power of 10. So here we have written A, 10 raised to B. What is B here? 2. A, 10 raised to 3. What is B here? 3. A, 10 raised to minus 3. What is the power here? Or what is B here? Minus 3. So 2 is the order of this measurement, 3 is the order of this measurement, minus 3 is the order of this measurement. Fine? Okay? So in this way, every type of measurement should be reported as a scientific notation given by A into 10 raised to B. So here we have removed the confusion. Then this confusion of the zeros also will not be there. Changing decimal confusion will not be there. Changing the unit confusion also will not be there. By representing the measurement in the form of a scientific notation. Right? Okay. And while deciding the significant numbers for a scientific notation measurement, we do not consider the 10 raised to be term itself, the power itself for the significant numbers. We consider only the base number is significant figures or numbers. Fine? Okay. Now there are point number 4 and 5 in the textbook, which are a repetition of the points in the zeros itself, rules of the zero. So I am not going into those 2 points. There is one last point which I am naming it as a 4, in which there are certain formulas which have a fixed number in it. Let us take an example. Circumference of a circle is equal to 2 pi r. Okay. Radius, this is just an example. Radius of a circle is equal to r. I can write it as d by 2. Here I have one number 2 which is multiplied. Here I have a number 2 which is divided. I can have one more formula as time period t is equal to the recorded time divided by number of oscillations n. N is also a number. Fine. Okay. So while taking significant numbers, these fixed values are exact numbers, are called exact numbers. These exact numbers are not rounded off. These exact numbers are not rounded off. They can be written as infinite number of significant figures, just like 2.0, 2.00, 2.000. I can write it like that. But they are considered to be as exact numbers, fixed numbers, which are not rounded off and which can be written with infinite significant numbers. Okay? Okay. And in these formulas, 2 here, 2 here and n here, they are not any measured values also. Fine? Okay? So these are exact numbers which are not rounded off. They are not rounded. They are not measured values, and they can be written in the form of infinite significant figures. Fine. So here this was the last point which comes under the rules of significant numbers. Fine. So I hope I have cleared the confusion in the rules of zeros and how to write down the significant numbers, taking into consideration the rules of zeros. How do I write it? As a scientific notation, where a is the base number and 10 raised to b is the number with a power. The power can be positive, the power can be negative. These powers are also called as the order of the magnitude. Fine. And last, there may be some formulas with some factors like 2, 2 and n here. These factors are exact numbers which are not rounded off. Okay? Not rounded off. They are not a measure value and they can be written in the form of infinite number of significant figures. Okay? So, I hope I have cleared the doubt in the mind how to write down the significant numbers. Fine. In the next section, we will find out how to determine the significant figures when you multiply two numbers and when you add two or subtract two numbers. Now, let us consider some few examples where we can solve or we can decide what is the significant number of this given value in the numerical. Or you can just say it is a number. First one. I'll give you time also to give your own answers, then we can solve it. Fine? Okay. So, I have a number here. Okay. Now, I have chosen certain numbers which are available to us in mathematics which we write. Now, this number has any number can have only one decimal point, that is known to all of us. Now, this number has a decimal point with 1 0 in between two digits and 1 0 after one digit. This number is less than 1 and it has zeros in front of digit 4. No zeros in between anywhere. This number has no digit but has two trailing zeros. This number has no zeros greater than 1. This number is in the form of A into 10 raised to B scientific notation form, and this number is having only 1 0 but it has a decimal also. Okay, so now we will write down the scientific figures for the example. There is no other available number possible other than these varieties which we have written here. Okay, so now how many significant figures do we write for this? I'll just put a tick for the ones which are yes and put a cross for ones which are no. Okay, so 1, 2, 3, 4, 5, 6. Fine. We considered this 0 because it is between 3 and 6. We also considered this trailing 0 because it is after a digit 8 and it can be the precision part. Fine. Okay. So how many? 6 significant numbers. Now here, because this number is less than 1, I have 1 0 here in front of 4, front of 4, front of 4. So they are not significant. And decimal is also there. So this number is less than 1. So how many significant figures does this number have? 3. 1, 2, 3. Not considering these 3 zeros because they are in front of the first digit 4. Okay. So 3. Now I have a number which does not have any decimal but it has a trailing zeros. Trailing zeros means the last zeros. So they are to be not considered as a significant numbers. So how many significant figures does this number have? 4. I have one simple number with no digits and no zero. So it is simple here. 1, 2, 3, 4. These are the significant figures or numbers this particular given number has. Okay, now here this is in the form of a scientific notation. So how do I write it as a into 10 raised to b? This is the base. I don't have to look at this at all for deciding the significant numbers. So how many significant numbers are there in the base number? 1, 2, 3, 4. Okay, so and remember the base is always greater than 1 and less than 10. Okay, so greater than 1, less than 10, between 1 and 10. Fine, so I have written it here. Now how many significant figures these are? 4. As discussed just now, only we have to consider the base number. Now this number has one trailing 0, but there is a decimal also. So I have to consider this 0 also, because this can be the precision of the given instrument. So what is my answer here? 2, 2. 1, 1. Answer is 2. Fine. Okay. So this way we have to decide the significant figures, digits, for a given number. Any number can be less than 1, can be greater than 1, but it can have either a decimal somewhere or no decimal anywhere. That is the time when you have to go back to the rules and remember what kind of a number is this, what kind of a number is this, and according to the rule decide the significant figures. Right? Okay, so this is a number with 2 decimal, so we have to consider the zeros, whether they are trailing, whether they are in between. This number is also a number with a decimal. We don't have to consider the zeros in front of the first digit, but somewhere behind, if it is there, we have to consider. This number has no decimal. It has trailing 0, so this trailing 0 don't consider. This number has no decimal and no trailing zeros. Clear? 1, 2, 3, 4. This number is written as a scientific notation, so we have to consider only the base number without considering this powered number. So only consider the base number. There is a 0 between. Take care of that and write the significant numbers as 1, 2, 3, 4. Decimal is also there, following the rule of the decimal and the zeros. Now this number 2.0, 0 can be the precision. It has a decimal, that's why it can be the precision. That's why you have to consider it as a significant figure. So I have written 1 plus 1, 2. I hope I am very clear with this varieties of number. There is no other variety of number possible for any measurement, according to me. If there is, then you can practice. So I'll just move now and you can take the screenshot of whatever we have learned just now. Fine.